From the sun-drenched valleys of California, where rows of almond trees stretch to the horizon like an emerald tide, comes a story of transformation. It's a narrative whispered by the wind through rustling leaves, carried on the hum of machinery, and finally, tasted in every delicate crunch. This isn't just about a nut, it's about an industry, a marvel of modern agriculture and engineering, meticulously designed to bring one of nature's most perfect foods to tables across the globe. We stand at the precipice of a hidden world, a realm where raw bounty meets cutting-edge technology, where the humble almond embarks on an extraordinary journey from orchard floor to packaged perfection. Prepare to step behind the veil, to witness the unseen forces, the precision, and the passion that define the modern almond processing plant. This is where the ordinary becomes extraordinary, where the everyday product you know so well reveals its astonishing, intricate origins. The almond, a seemingly simple drupe, holds within its shell a universe of fascinating details, a history steeped in ancient lore, and a modern story of agricultural innovation that borders on the miraculous. Did you know that despite its common classification, the almond isn't actually a true nut? Botanically, it's the seed of the fruit of the almond tree, a close relative of peaches and cherries. This botanical distinction is more than just a scientific footnote. It hints at the complex life cycle and delicate nature of this beloved food. Its origins trace back to the Middle East, where it was one of the earliest cultivated trees, revered for its nutritional value and medicinal properties. Ancient Egyptians included almonds in the provisions for pharaohs' tombs, believing they offered sustenance in the afterlife. The Romans, too, held them in high esteem, scattering them at weddings as a fertility charm. But how did this ancient seed become a global phenomenon, with California alone producing over 80% of the world's supply? The answer lies in a confluence of ideal climate, pioneering agricultural practices, and relentless innovation. The Central Valley of California, with its Mediterranean climate of hot, dry summers and mild, wet winters, provides the perfect conditions for almond trees to thrive. However, this wasn't always the case. Early attempts at almond cultivation in California were fraught with challenges, from unpredictable weather patterns to pest infestations. It was through decades of dedicated research, crossbreeding, and the development of sophisticated irrigation techniques that the region transformed into the almond powerhouse it is today. Consider the sheer scale of this operation. A single almond tree can produce thousands of almonds, and a typical orchard can span hundreds, even thousands, of acres. The harvest itself is a spectacle of modern agriculture. Unlike many fruits that are handpicked, almonds are shaken from their trees. Giant mechanical shakers grasp the tree trunks and vibrate them vigorously for a few seconds, causing the ripe almonds to fall onto the ground. This process, which might seem brutal, is incredibly efficient, allowing vast orchards to be harvested in a fraction of the time it would take manually. But the journey doesn't end there. The almonds, still in their outer hulls, are then swept into rows by specialized machinery and left to dry naturally in the sun for several days. This sun-drying process is crucial. It reduces the moisture content, preventing mold, and preparing them for the next stages of processing. The evolution of almond varieties is another testament to human ingenuity. There are hundreds of almond varieties, each with unique characteristics in terms of size, shape, flavor, and skin texture. Nonpareil, California, and Mission are among the most popular, each favored for different culinary applications. Nonpareil, with its smooth, easily blanched skin and elegant shape, is often preferred for confectionery and as a snack. California varieties are versatile, used in a wide range of products, while Mission almonds, with their darker, wrinkled skins, are prized for their robust flavor, often used in baking or as roasted snacks. The development of these varieties wasn't accidental. It was the result of meticulous breeding programs aimed at enhancing desirable traits, improving yield, and increasing disease resistance. And what about the health benefits? For centuries, almonds have been lauded for their nutritional profile, but modern science has only recently begun to fully unravel their remarkable properties. Rich in monounsaturated fats, fiber, vitamin A, magnesium, and antioxidants, almonds are a nutritional powerhouse. Studies have linked regular almond consumption to improve heart health, better blood sugar control, and even weight management. The sheer density of nutrients packed into each small kernel is truly astonishing, making them a staple in healthy diets worldwide. This widespread recognition of their health benefits has fueled an unprecedented demand, pushing the industry to new heights of efficiency and innovation. The global reach of the almond is equally impressive. From the marzipan of Europe to the traditional sweets of India, from the almond milk laddies in bustling city cafes to the healthy snack packs in school lunchboxes, almonds are ubiquitous. This global demand presents unique challenges in terms of logistics, quality control, and sustainability. Every almond that leaves a California processing plant must meet stringent international standards, ensuring consistency and safety for consumers across diverse cultures and culinary traditions. The journey from a sun-drenched orchard to a supermarket shelf thousands of miles away is a testament to a highly sophisticated supply chain, a marvel of modern commerce that often goes unnoticed. Consider the sheer volume. California's almond industry produces billions of pounds of almonds annually. To put that into perspective, if you were to line up all the almonds produced in a single year, they would stretch around the earth multiple times. This massive output requires not only vast agricultural lands, but also an equally vast and efficient processing infrastructure. The plants themselves are not just buildings. They are intricate ecosystems of machinery, technology, and human expertise, all working in concert to transform a raw agricultural product into a consumer-ready food item. The precision required at each stage, from hulling and shelling to sorting and packaging, is mind-boggling, a symphony of automation and human oversight. Even the waste products of almond processing are valuable. The hulls, the fibrous outer layer of the almond fruit, are not discarded but are primarily used as livestock feed, particularly for dairy cows. The shells, once removed, are often used as biomass fuel to generate electricity, contributing to the sustainability of the industry. This commitment to utilizing every part of the almond, minimizing waste, and maximizing resource efficiency is a hallmark of modern agricultural practices. It's a testament to an industry that understands its responsibility not just to its consumers, but to the environment that sustains it. The almond story is one of ancient wisdom meeting modern science, a journey from a humble seed to a global superfood, meticulously crafted and delivered with unparalleled precision. The journey of the almond from the orchard floor to its final packaged form is a meticulously orchestrated ballet of machinery, technology, and human expertise. It begins with the arrival of the harvested almonds at the processing plant. These aren't the familiar shelled almonds you buy in stores. They arrive as orchard run, meaning they are still encased in their fibrous outer hull and hard inner shell, often mixed with twigs, leaves, and other debris from the harvest. The first critical step is the receiving and pre-cleaning. Large trucks deliver the orchard run almonds to the plant, where they are unloaded into massive hoppers. From there, they are conveyed through a series of screens and air separators. These initial stages are designed to remove the larger foreign materials, leaves, sticks, and dirt, before the more delicate processing begins. Powerful vacuums and vibrating screens work in tandem to sift out unwanted elements, ensuring that only the almonds proceed to the next stage. Next comes the hulling process. The hull is the soft, green, peach-like outer layer that encases the almond shell. This layer dries and splits open on the tree, allowing the almond to be shaken free. At the plant, specialized hulling machines gently remove this fibrous outer layer. These machines use rollers and abrasive surfaces to separate the hull from the shell without damaging the almond kernel inside. The hulls, as mentioned, are a valuable byproduct, often collected and processed for livestock feed. Following hulling is the shelling stage. This is where the hard, protective outer shell is cracked open to reveal the edible kernel. Shelling machines are precisely calibrated to apply just enough pressure to crack the shell without crushing the delicate almond inside. There are various types of shellers, including impact shellers and roller shellers, each designed to maximize efficiency and minimize damage. The goal is to achieve a high percentage of whole kernels, as broken pieces command a lower market price. Once shelled, the almonds, now a mix of kernels and shell fragments, move to the separation stage. This is a crucial step where advanced technology comes into play. Air classifiers, vibrating screens, and gravity tables are used to separate the lighter shell fragments from the heavier almond kernels. The principle is simple. Different densities and sizes allow for effective separation. Air currents lift away lighter shell pieces, while vibrating screens sort by size, and gravity tables use slight inclines and vibrations to separate based on density. This multi-stage separation ensures a clean product. Then comes the meticulous sorting process. Even after mechanical separation, some foreign materials or imperfect almonds might remain. This is where optical sorters, a marvel of modern technology, play a vital role. These machines use high-resolution cameras and advanced algorithms to scan each almond as it passes by. They can detect subtle differences in color, shape, and even surface imperfections, instantly identifying and ejecting any almonds that don't meet quality standards. This automated sorting is incredibly fast and precise, far surpassing the capabilities of human inspection alone, though human inspectors are still present for oversight and final checks. After sorting, the almonds are often subjected to a pasteurization process. This is a critical food safety step, especially for almonds destined for raw consumption or use in products that won't be cooked. The most common method in California is steam pasteurization, where almonds are briefly exposed to high-temperature steam to eliminate potential pathogens like salmonella, without significantly altering their taste, texture, or nutritional profile. Another method is propylene oxide, PPO, treatment, though steam pasteurization is increasingly preferred due to consumer demand for chemical-free processes. Following pasteurization, the almonds are ready for further processing or packaging. Some almonds might undergo blanching, where they are briefly immersed in hot water to loosen their skins, which are then removed by rollers. Blanched almonds are prized for their smooth texture and clean appearance, often used in confectionery, baking, and as a snack. Others might be roasted, either dry roasted or oil roasted, to enhance their flavor and crunch. Flavoring, such as salting or seasoning, might also occur at this stage. Finally, the almonds move to the packaging lines. Here, automated systems weigh, fill, and seal packages of various sizes, from small snack bags to large bulk containers. Robotics are often employed for precise handling and palletizing. Throughout the entire process, stringent quality control measures are in place. Samples are regularly taken and tested for moisture content, microbial contamination, foreign materials, and overall quality. This continuous monitoring ensures that every almond leaving the plant meets the highest standards of safety and excellence. The entire operation is a testament to industrial efficiency, where nature's bounty is transformed into a perfectly processed product ready for global distribution. And so, we conclude our journey inside the modern almond processing plant, a place where nature's simple gift is transformed through a symphony of innovation and precision. From the sun-drenched orchards to the intricate dance of machinery, we've witnessed the hidden world behind every crunchy bite. It's a testament to human ingenuity, a relentless pursuit of perfection that ensures quality, safety, and sustainability. But the world of food production is vast and endlessly fascinating. Have you ever wondered what truly goes into creating those perfectly uniform, irresistibly crispy chicken nuggets? What advanced technologies are at play, and how do they ensure consistency and taste in every single piece? If you're curious to uncover the secrets of another high-tech food factory, then you won't want to miss our next episode, which just appeared on your screen. Before you go, if you've been captivated by the intricate processes and surprising facts we've shared today, please consider subscribing to our channel. Your support helps us continue to bring these incredible stories of industrial marvels to life. And tell us in the comments below, what was the most surprising fact you learned about almonds today? Was it their botanical classification, the scale of the harvest, or perhaps the meticulous sorting process? We'd love to hear your thoughts.